Okay, let's look at number 27. And I think this problem could be misinterpreted depending on how you read it, because I know the first time I read it differently. But it says you've got this track that is going to be constructed in the shape of a rectangle with semicircles at each end. So, like, it tells you that this much is x, this much is x. Now, since these are semicircles, this is really the circumference of one circle. So you basically are looking at x plus the circumference of a circle. And it says that the track is 440 yards long. That's the part that I think is confusing, because you could just read that as the length. I know I did originally. But I believe what it's trying to say is that all the way around the track one time, so the perimeter of the track is actually 440 yards. So we do know that this measurement right here, because it's basically a circle, right, is a radius. So if I need to get this whole dimension at some point, that's going to be 2r, because that's a diameter, which would be 2 radii. Okay, so let's talk about what we know. We know that x plus x is, of course, 2x. We know that the circumference is either pi times diameter, but you can write that as 2 pi r, because the diameter is 2 radii. And all of that is going to equal 440. And so basically I'm using perimeter, the concept of perimeter. Now, what it wants me to do is express the area of the region enclosed by the track. So it's actually wanting me to do, I'm going to color this all in green. It's actually wanting me to find the area of kind of that grass portion. So the area is going to be a rectangle plus a circle, if you were doing that in words. So I'm going to say, okay, A of R is equal to the rectangle. Well, let's see if I know the dimensions. I'm just going to start with 2R times X. That would be the rectangle. And then to find the area of a circle, it's going to be pi r squared. So this function is fine, but the problem says I need to have it as a function in terms of r. So this x right here, I need to get rid of. Well, that's when I can use my perimeter equation above, and I can isolate the x value. Now, looking at it, I'm going to go ahead and divide everything by 2, just because it'll give me easier numbers. So I can say that's the same as x plus pi r equals 220. And then I still just need to get x by itself. So I'm going to subtract that pi r. So that's going to give me x is the same as 220 minus pi r. So now I'm going to plug in what I know. I know that my 2r is 2r. I know that my x is 220 minus pi r. And then I'm not going to forget that I still have to add that circle to find the area. And I'm just going to keep going. So I'm going to go ahead and multiply 2r times my quantity 220 minus pi r. So that's going to give me what? 440r minus 2 pi r squared. And then I'm going to bring down the plus pi r squared. And I can simplify a little bit more, it looks like. So I can combine like terms. I've got 440r minus pi r squared. So that is a function of the area of that grassy region in terms of r. Now also, just one step further, if you wanted to write it in factored form, you would factor out that r, and you would have 440 minus pi r. So either way is appropriate.